Welcome to our August 2026 threat briefing. This month, we will analyze 3 recent breaches looking for lessons that we can take away and improve our own security posture. Our first story comes from the semiconductor industry, with exactly the kind of high-value target that attackers love. In February 2026, Advantest, the chip testing equipment giant behind machines that validate processors for Intel, Samsung, and TSMC, disclosed that an unauthorized third party had broken into its network and deployed ransomware. The company admitted that its hackers may have gained access to portions of the network. The problem, of course, is that a relatively flat or unsegmented network, portions can turn into access to everything rather quickly. One foothold in a business laptop suddenly becomes a straight line to design files and production adjacent systems feeding the global chip supply chain. A situation like this is a classic case for isolating critical assets with virtual chambers. That same intrusion gets boxed in immediately because every workload sits behind its own zero trust boundary. Chambers eliminate lateral movement, command and control callbacks, and end ransomware propagation. The blast radius shrinks from the whole network to just one isolated chamber before the attacker even knows they've been contained. Our second breach should worry every team experimenting with AI agents. We're going to look at an AI agent that did exactly what it was told, just not by the right person. Salesforce's Agentforce let anyone submit a lead through a public web form with a rather generous 42,000 character description field. An attacker buried a hidden instruction there and then bought an expired domain for $5. This one happened to be still sitting on Agentforce's allow list as a trusted domain. So when an employee later asked the agent to summarize that lead, it read the buried instruction as a real command and quietly shipped customer records out through what looked like a routine image request to that $5 domain. Nobody clicked on anything. The agent just followed the last instruction that it saw, regardless of where it came from. And that's the exact gap that declared intent enforcement is designed to solve. Every session needs to start with a declared scope of what the agent is actually there to do. Then, when a hidden instruction pushes it toward an undeclared destination, an inline control like Zentera's AI session controller catches the mismatch and blocks the connection before a single record leaves the building. In our third story, a trusted vendor became a doorway that the attackers used. Between late 25 and February of 26, attackers compromised a third-party vendor with standing access into one of the major hospital system networks and sat there undetected for roughly 3 months, quietly copying files. When it surfaced, the damage was staggering. 1.8 million people's social security numbers, financial data, medical records, even fingerprint and palm print biometrics that can never be reissued. The root problem is one that we see constantly. Vendors get broad network trust instead of narrow, purpose-built access. In situations like this, the combination of chambers and tight ZTNA and user access controls is needed to give outside partners a tightly scoped path to only the resources they need. Once the pathways for lateral movement have been eliminated and third-party users are tightly controlled, a compromised vendor account just can't turn into a 3-month, 1.8 million record disaster. The access path simply isn't there to exploit. Well, that's it for this month. As agentic AI adoption accelerates, we all have work to do. If you need better critical asset protection or agentic AI controls, reach out to us at www.zentera.net, and we'll look forward to seeing you next month.